Okay, thank you. Thank you, Richard, for sharing Lazada's impactful work with Flink and Holograph to optimize the e-commerce platform. And for our final session of today, we'd like to welcome Danny, Regional Product Solution Architect at OceanBase. Danny will present building a real-time data warehouse with Flink and OceanBase. Okay, welcome, Danny.
Thank you. Thank you, and good afternoon. It's certainly been a long day. I am acutely aware I am standing between you all and the end of the day and maybe an ice cold beer, so I will move on. I'm a solutions architect at OceanBase. So before I start, could I just have a show of hands if you've heard of OceanBase before, or you've perhaps used it? Keep them up. Obviously, you're running the event. So I mean, I've been working with databases and data for about 25 years. I must confess myself, I heard of OceanBase only about 2 years ago. So let's move on. But they've actually been around for 15 years. It started as a project within Ali to build a distributed, scalable database. So it does have a long history, and we'll talk a little bit about Ali and how they use it in a moment. But it's the leading distributed database for hybrid workloads, deals with data volumes from hundreds of gigabytes up to petabyte scale. And it's been extremely effective from the users who are using it at reducing costs when it's run at scale. We actually have more than 2,000 global customers, and we'll talk about a few of those as we move through. So in terms of performance, everyone's always interested in performance. OceanBase in 2020 broke the Transaction Processing Council TPCC world record. Now, it didn't just break it, it broke it by 23 times the performance of the previous Oracle record. So that's quite an impressive number. What I find more interesting about this, though, is in 2021, it also broke the TPC-H world record. Now, if you think about databases, they're usually designed to do one thing very well. Perhaps they do transactions very well, or perhaps they do OLAP very well. OceanBase, the same database engine, broke both of these world records. So pretty impressive on the performance side. It's gaining traction through industry analysts, the usual suspects, Gartner, Forrester, IDC. We have also contributed more than 20 scientific papers at some of the global database conferences. We've got a bunch of customers globally, some of the logos there. But if we look at some of this in more detail, in banking, for instance, in China, we currently are used by about 70% of Chinese banks for their core banking mission-critical systems. 85% of those are state banks with more than $150 billion under management, and we are starting to gain traction as we expand into some of the global banks. In other industries, we're doing pretty well. 70% of insurance companies. We serve about 20% of Chinese mobile users running the back-end systems for the telcos, transport and logistics, manufacturing, and retail. Let's talk about one of those customers on there. I think this is the wrong slide deck, but it's not been updated, but never mind. I was going to talk about PopMart, but instead I will talk about Chris Skinner. I'm not sure if you're familiar with him, if you follow the financial technology news. He's been recognized as one of the industry's leading commentators in that space. He put a post out on Twitter in 2019, and he was contrasting Visa. So if you think of the Visa global payment network, they peak out at about 64,000 transactions per second. Now, if you contrast that with Alipay and events like the Double 11 sale, they're processing 544,000 transactions a second. Now, that's a staggering number. I'm having trouble myself just processing how many people must be shopping online at the same time to produce that number. But that's the kind of volume we're talking about here. Digging into Alipay a little bit more, Alipay have been running on OceanBase for the last 10 years. This is even before OceanBase became commercially available, which was about 6 years ago. They currently have 6 petabytes of data sat in one OceanBase cluster. And the biggest table, it's about 690 billion rows. So this is a lot of data. They have all of this in one cluster. Now, that cluster scales. They usually run it at a couple of hundred nodes. When it comes to the Double 11 shopping event, they've got 2 DBAs who manage this, and they scale that cluster to more than 1,000 nodes to cope with the traffic for that event. And that whole process takes about 2 to 3 hours, and it happens completely seamlessly. No interruption to any of the payment services that run on top of it. That allows them to run about 61 million queries a second, which is, again, a frighteningly high number, and 544 transactions a second that we mentioned. So that's all done in real time by 2 DBAs. If you think about what's driving growth amongst some of the new database companies, well, there's a few factors. Real-time analytics is a big thing, and it has been for years. That's certainly one factor. We have the cloud. We have businesses who need to scale to cope with different volumes. That's another factor. And then multi-model. Over the last 15 years, we started off with storing rows of data. Then we've progressed to storing columns of data. We've got key value stores. We've got geospatial data. We've got wide data columns. We've got vectors. So the landscape has changed, and that's certainly driving a lot of the growth in new database companies. And then, of course, we have the open source community. Open source adoption into these technologies is further driving that growth. So if you look at OceanBase's journey, it's gone down the same path. We started as a distributed OLTP database. We then expanded that out into analytics with column store. We have gone on to provide different models such as key value stores, document stores, AI engines in the same database. So the product itself has evolved over 15 years. It's now a multi-model database, can be installed on multi-cloud, and it's capable of managing any mission-critical workload. If we look at the old-school way of doing data warehousing, so on the right-hand side here, we might have an OLTP application. It's writing to a standard row store, and then we used to have maybe an ETL process, right? So every night we would take that data, the transactional data, we would move it into an OLAP database, and there we would process it. That's a very wasteful model. We're storing the data twice. The other problem is you've got a significant lag between your transactional data and your reporting data. So OceanBase solves that problem because all of this is now in the same engine. So we can take data from OLTP apps, put them in a row store, and then we can build column store indexes on top of that, or materialized views into column store, all in the same engine. And that gets rid of the lag. So instead of querying yesterday's data, you're now querying the transactional data as it comes in real time. On top of this, we start with the SQL side of things, running OLTP and OLAP on the left. We have NoSQL support, so we've got APIs that can integrate, so we can support JSON, documents, and so on. And I want to spend a little bit of time talking about this vector engine, because this is what integrates with a lot of the AI use cases today and large language models. So if you think about a simple question, recommend a Thai restaurant within 500 meters, average spend lower than $300, the rating's more than 4.5, and it's got good comments. If you break that down, what are you actually doing there? Well, if you look at the structured section, we've been doing this for years, right? So give me a B-tree index, find me anything that's less than $300 and more than 4.5 stars. We've got a spatial index being used there to find the restaurants that are close to me. Vectors, give me the good comments. What is a good comment? Back in the old days, we might search for the word good. But with vectors and large language models, we can do better than that. We can take those reviews, we can run them through an LLM, we can attach a vector to that data. So even if somebody has left a review saying that was fabulous or it was yummy, we are now gaining the context of the text, the semantics, not just the syntax. So the search engine allows us to search through that rapidly, and that's what allows us to integrate with some of these AI cases. Gcash, another company who've scaled massively over the years. If you think about these e-wallets, particularly in emerging markets around here, you've got a lot of people who live outside of cities. They may not have access to banks. So the emergence of e-wallets and mobile payment systems has caused a huge explosion in uptake. So companies have gone through rapid growth. Gcash approached us. They were running MySQL. They couldn't cope with the amount of scale they were going through in their business. Since moving to OceanBase, they've got 5 times the number of SQL connections. They've taken an estate of 200 MySQL instances and consolidated that down into 10 OceanBase clusters. And that saved them about 40% on cloud infrastructure costs. As well as that, OceanBase has got a very sophisticated data reduction capability, compression, and deduplication. We typically save customers about 70% on their data storage costs. Popmart, we were talking about Popmart earlier. So again, they started off very small, gone through unprecedented growth, which they couldn't cope with. They do flash sales, so their business peaks up and down. They need to scale up and down rapidly. They approached OceanBase. The way OceanBase works is it's one big cluster, and we create MySQL compatible tenants or Oracle compatible tenants in that cluster. Now those tenants can be scaled multi-dimensionally. So we can scale vertically. We can increase the CPUs and memory to one tenant. We can scale vertically at the VM level. We can do the same there. We can scale horizontally by adding more nodes into the cluster. So that flexible scale that's non-disruptive has allowed them to manage the business, shrink it up and down as they do these promotion events. We do, talking about Flink, Flink integrates with lots of different data sources. OceanBase is one of those. We do have full compatibility with MySQL binlogs. So if you're using those today, connecting to MySQL, OceanBase allows you to do the same with no code changes, no driver changes. Apache HBase, we've been used as a replacement for this in multiple different use cases. Some of the use cases, I think I might have the slide a little bit further down. So an example that a customer using this and integrating with Flink. So previously they were ingesting data from MySQL. They were using Alibaba Canal into Flink with a sync into HBase. Now, because HBase doesn't have a materialized view capability, they had to write their own custom CDC to pull the data back out into Kafka and then into their OLAP database, which is quite a complex workflow. What they've done with OceanBase, firstly, they could use the Flink CDC, which has got the native integration into MySQL, goes directly into OceanBase. We do support direct load capability as well, which bypasses the SQL engine. And then from there, they can use materialized views to move that data into column store and then present it out to the dashboard straight away. So you've simplified the pipeline, reduced components, and in their case, I think they saved about 50% on their costs of doing that. On the top, going through this process, I think the dashboards were real time to about 20 seconds. Putting OceanBase in and removing some of those layers, it's down to 5 seconds. So again, this is more about the binlog side of things. So all of these different CDCs, Canal, Debezium, Flink, all work natively. I think it's compatible with MySQL binlog version 4. And it just, particularly in the space of Flink, it supports snapshots. So you can get the full data. You can also get the incremental data. And then when using Flink, you've also got the parallel execution and the transformation capabilities. So it's a great combination. again, just an illustration of connecting to various different data sources and being able to put that into OceanBase. So some of the capabilities we talked about before, the partition sync. We have done a lot of work here working with Flink on our integration, which allows us to support some of the advanced features of OceanBase. I'll touch on one of them, which is the direct load. So we're no longer going through the SQL engine, and we're just getting the data in as quickly as we can. I won't get into the techie details here, but an example of how you might set that CDC up and get it to read directly from OceanBase. And this is more specific around where the general data warehouse use cases. So if you think of being able to pull your real-time data in real time into an operational data store, that could be in a column storage, and then being able to have Flink orchestrate that through the different layers. So we have data warehouse detail, data warehouse summary, and then down to the presentation layer, and that's all orchestrated by Flink. And you've not had to pull that data around and move it through various different components. It's all happening in the same database engine. An example of what we talked about earlier, where we've got a MySQL source table, just a standard row table, and Flink is pulling that out, and it's then streaming that to OceanBase and converting it into a column store. So by doing that, we've got some stats on the right-hand side here. Just taking those car orders which are going in here, putting it through the pipeline, just displaying those, I think it was about 9 milliseconds, right? But when you want to then aggregate that data, so let's say we want to group that data by the car color, and that's a group by and a sum aggregation, that's happening in 132 milliseconds on 151 million rows. So pretty fast and flexible. What are we doing next? In terms of OLTP, we do have a database as a service which runs on all of the major cloud vendors. We are always looking for ways to reduce the cost of that. We're already quite competitive compared to the other players in this market. But we are doing things like integrating with object storage to offload some of that data away from the SSDs in the nodes, reduces the cost. We're also looking at serverless to reduce the compute cost. On the OLAP side, we're always looking to improve performance, provide support for BigQuery, and we are building in a native data lakehouse. AI, vector search, we continue to improve on that, and we are also integrating into a wider ecosystem of AI players. We're working with DeepSeek at the moment, so expect large language models inside the database engine, and then the logical progression from that is native query. So being able to go to your boss, or your boss being able to just type in, give me the sales reports broken down by district in natural language, and that will query the underlying engine. So I think that's it. I hope I've pulled back a little bit of time and given you some time back today. I am available for questions. You can either ask them now or I'll hang around for a bit, and if you've got anything specific, come and speak to me. But again, thanks for listening. Hope it's been a good and fruitful day in terms of picking up some new skills and meeting some new people, and thanks again. Yes, sir.
Open source, right?
So,
to run this, do we need to go for cloud or we host it in cloud?
Yeah, so the question was, is OceanBase open source, and I guess what are the deployment models? So there is a community version of OceanBase, which of course is free to download. You can run it as a single node. If you're going into the enterprise space where you want resilience, we're then talking about the enterprise edition. That can be deployed on-prem. So it's got the full ecosystem of management tools, or it runs as a service on all the clouds. So AWS, Azure, GCP, Tencent Cloud, Huawei Cloud. It's available as an option to run on those, which is obviously a kind of pay-as-you-go OpEx model. So, yeah.
So in terms of the benchmark testing, how do you compare like OceanBase to PolarDB? PolarDB is the one like tops in.
Yeah. So I mean, it's interesting because this has gone on for years, right? There's been battles around who's got the fastest and how do you judge it fairly? Because you look at Oracle RAC, that used to hold the record back in the day, but it was kind of limited to 8 nodes. You couldn't push it beyond that before it starts to fall over. With a distributed database, the architecture is very different, so you have unlimited scale. So in the case of OceanBase taking that title back in 2020, they're throwing 1,000 nodes at it, right? So I believe PolarDB have now taken that record again, but it's a matter of scale, right? You want to put 2,000 nodes in there, 3,000 nodes. So I think the fairer judgment is around cost per transaction, right? So that's the way. But I mean, I'm pretty confident if we wanted to go and throw 2,000 nodes at it too, we'll take that back. But it's, as you say, it's one of those things. It's people try and strive to get that, but really, is that how your business works? Probably not. Your business is not, unless you're in the bit, these TPC benchmarks, they're like a warehousing e-commerce solution with, taking forward. Is that exactly what your business does? No. What you're really interested in is how is this going to perform for your business, which of course you will not find out until you try it. Yeah.
Just you mentioned the Oracle RAC.
Yes.
OceanBase compared with Oracle RAC.
Yeah.
Oracle RAC.
Yeah, so Oracle RAC, so actually Ali used to run on Oracle RAC, and that's the reason why they started developing this, because they got to 8 nodes, and on this 11 shopping day, it just fell over, and there's no way it could cope, and you can't really scale it beyond 8 nodes. So what they've done here is have a very high level of compatibility with Oracle, about 95% compatible. So if you are an Oracle user, and you are sick of the extortionate license fees and maybe not the best support in the world, there is an off-ramp. So OceanBase is actually the only distributed database out of the 4 or 5 players at the moment that have that Oracle compatibility. So Oracle and MySQL are the 2 formats that we support. Yeah. Okay. I think we are about wrapped up on questions. So thank you all again. Thanks for hanging around for so long, and wish you all a good evening.
Thank you.
Thank you. Cheers.
Thank you. Thank you, Danny, for the wonderful talk. Okay, and I think we wrap up our real-time analytics track 1. So before we close, I'm excited to let you know that about our next major thing, the Flink Forward Barcelona 2025. Yeah. So it is happening in October 13 to 16. And this will be another incredible opportunity to connect with the global Apache Flink Apache Flink community to deep dive into some technology innovations and explore more groundbreaking things. And we warmly invite you to join us in Barcelona to learn more about the event. So you can simply scan the QR code on the screen now for more information. And last thing, speakers and attendees are welcome to take group photos at the Island Ballroom, which is the main stage in this morning keynote. So on the 3rd floor, so it's welcome to take photos here. And thank you again for being part of Flink Forward Asia 2025, and see you in Barcelona and next year's Flink Forward Asia. Thank you.